So by this point in your inquiry, you've discovered the relationship between degrees and this new kind of angle measurement, which is a little bit more natural because it's measuring the size of an angle in terms of the length of the arc relative to its radius that it subtends. That's kind of got a natural feel to it. And so degrees are nice when we're speaking to each other because having a right angle, giving that a nice clean number like 90 degrees has a certain nice feel to us as humans, understanding, the things that happen a lot in the world around us. But when you get to calculus, you'll find that the natural beauty of radians is worth the inconvenience of doing all of your measurement and calculations in terms of radians instead of degrees. So both of these measurements have their value in the modern world. Let's talk about how to convert between them then. So we've got this key idea that you came up with that 180 degrees is equal to pi radians. And so we're going to use this conversion factor to convert between angles in exactly the same way that you've done this for other kinds of conversions, probably mostly in middle school. That if I told you that there were 4 quarts in a gallon and wanted to know how many quarts there were in 17 gallons, you might set up a proportion using this as one of your factors. So for instance, let's say that I wanted to express 30 degrees in terms of radians. All right, in radians. So what I'll do is I'm going to set up a proportion. I'm going to say 180 degrees is to pi radians equals 30 degrees over x. And now I've got this equation that I can solve for x. Notice that this side is my conversion, and I'm making sure that the degrees line up and the radians line up. So here I just cross multiply, and so I have 180x is equal to 30 times pi. So to find out what x is, I'm just going to divide both sides by 180. And I've got x is equal to, well, let's simplify this a little bit. First thing I can do is I can kick out these zeros. Can I do any more simplifying? Yeah, well, 18 is equal to 3 times 6. So I can cancel out that 3 and turn that into a 6. And so 30 degrees is equal to pi over 6 radians. All right, so there's my conversion factor. And you can use this to convert between radians and degrees, just the same thing, except that here is going to be the number of radians and x is going to be the variable that you solve for. So give that a shot in the rest of the units and the rest of the questions in the work packet, converting between radians and degrees. And what we're going to find in the next couple videos is that there are some formulas that are going to have some nice elegance to them if we're doing our measure in radians, but we're going to have to do a little bit of extra proportion work if we want to solve them in terms of degrees. So keep an eye out for that.